Welcome to Get Your FRQ On. In this tutorial, I'm going to show you how to explore the graphical relationship between a function and its inverse. So the first thing we're going to want to do is just choose some function that we want to graph the inverse for. So I'm going to go to my function editor, and I'm just going to enter some random quadratic expression here, x squared minus 5x, and let's say minus 2. So I graph that. One of the things I'm going to want to do before I explore this relationship is I'm going to want to make sure that my window is set to zoom square. So zoom and zoom square is number 5, so I'm just going to make sure that that happens. And then the way you would access the graph of the inverse here is on this calculator, I'm going to go to second program, and notice the second function for program is a menu option called draw. All right, so I'm going to do that. Second program, draw. Well, what do I want to draw? Look all the way down here. This is the 8th option here. So I'm going to go down to that, and I'm just going to click on the plus to indicate what the syntax for using this menu option is. I can choose the expression that's going to be from my variables menu. So if I have a function in y1, I'm going to go to variables and use function y1. And if I happen to know the code for whatever color I want it to draw in, I can make it draw in that color. The default here is to match the color of the original function. So the original function, I think, as I recall, was in blue. If I don't set that option, it will just draw the inverse in blue as well. All right, so now that I know how to input this, draw inverse function y variables function y1, and notice it draws the inverse. All right, now something you might notice, and if you've studied inverses before, you may already know this, there does seem to be a geometric relationship between these two graphs. In fact, they are reflections of one another over a very specific line. What line is it? Well, it's the line that's going to go through this point down here where the two graphs intersect, and this point up here where the two graphs intersect. And a keen observer may hypothesize that the line that goes through those 2 points is in fact the line y equals x. So just to verify that, I'm actually going to graph the line y equals x. So I go back to graph it, and lo and behold, the line y equals x does in fact go through the 2 points of intersection. And if you've studied inverse functions before, you may know this, that the graph of a function and its inverse are supposed to be reflected images of one another over the line y equals x. So this would not come as a surprise to you. But that is a pretty interesting revelation about the graph of a function and its inverse. In fact, when you study inverses, you may have learned that you can get the inverse of a function simply by switching the x and y coordinates around for all of the points, the ordered pairs on that graph. If we do that, then we're just going to get a reflected image over the line y equals x. So maybe you recall that from geometry. Either way, there is this geometric relationship between these two graphs.